In this video we're going to look at a specific example of homogeneous catalysis called autocatalysis. And autocatalysis is where the catalyst that we're going to be using is actually a product of the original reaction. So an autocatalyst is when the catalyst for the reaction is a reaction product. And an example of this in A-level chemistry is the reaction between manganate ions and ethane dioate ions. We can see that Mn2 plus that is produced is going to act as our catalyst. So here we have our autocatalyst in this example is Mn2 plus. Let's just do that again. So autocatalyst is going to be the Mn2 plus. You can see it's a product of the reaction. What we see when we follow this reaction, we can follow this reaction quite easily because MnO4 minus, the reactant, is a purple colour. So if we use a colorimeter, we'll be able to monitor the amount of purple in the solution, and that will directly link to the concentration. So we'll be able to plot a concentration time graph. What we see is at first the reaction, the graph is fairly level because the reaction is very slow. And remember, on a concentration time graph, the gradient is representing the rate. Then all of a sudden, the gradient speeds up. I'll just do that line again. So all of a sudden we go from being fairly level to being fairly steep, and then we gradually slow down and taper off as the reaction stops. Okay, so we've got three parts to this graph. We've got a bit at the top where it's fairly level at the start, as the reaction is slow. And why would the reaction be slow at the start? So have a look at the overall equation and think, why would the reaction be slow at the start? And it's slow at the start because the two species reacting are both negative ions, and the negative reacting ions repel one another, and that means that the activation energy is going to be high. So this beginning part of the curve here is uncatalyzed. We've just got these negative ions and it's very slow. Then what happens all of a sudden is Mn2 plus is formed and the rate increases, so it gets much steeper. We're going to see rate increases as Mn2 plus is formed. And then at the very end, it seems to slow down and taper off. And that's as the MnO4 minus, the manganate, is used up. The reaction slows down and stops. Okay, so we've got these three parts of the curve. Now we need to be able to explain, using equations, what's going on in this reaction. So let's have another look. We've got the overall equation written again here. 2 MnO4 minus and 5 ethane dioate ions reacting in acidic conditions to make Mn2 plus water and carbon dioxide. So we said initially the rate is very slow as the reacting ions are both negative. So repel one another. As a result of that, the activation energy is very high. What happens then is some Mn2 plus forms. Now Mn2 plus is able to be oxidized to Mn3 plus. And that's how it's going to act as a catalyst, and it reacts with the MnO4 minus. So if we just take it back a minute and think about our half equations. So what would be happening? We've got Mn2 plus that has now been formed is going to be able to be oxidized to Mn3 plus. We'll balance that with an electron. And the MnO4 minus is going to be reduced to Mn2 plus. So we can think about balancing this equation, 1 Mn on each side, add 4 waters to balance the oxygen, add 8 H pluses to balance the hydrogen ion atoms with hydrogen ions, and add 5 electrons to balance the charge. So if I wanted to combine these to find out what's going on at this stage, I would need to multiply this top equation by 5, so that both equations have 5 electrons, and then combine them. So I'm just writing down everything. I'm going to lose the electrons because we balanced those out, but I'm also noticing that I've ended up with Mn2 plus on both sides, so I'm going to cancel that down as well. So I'll cancel this one with one of these, so I'm going to end up with 4, and this is what's going on at this stage. So once I form some Mn2 plus, it's able to react with my manganate to produce some Mn3 plus. So let's write that in. So we worked out that we had 4 Mn2 plus overall reacting with our manganate and acid to form 5 Mn3 plus and 4 waters. This step is going to be a lot faster because now we've got oppositely charged ions and they attract one another, lowering the activation energy. Okay, so now what happens is we've got Mn3 plus, and Mn3 plus is going to be able to react with our other ion, our ethane dioate ion. So now the Mn3 plus we formed, because it's going to act as a catalyst, is going to be reduced back to Mn2 plus, and ethane dioate ions are going to be oxidised to our other product, carbon dioxide. So again, we can use our rules, balance the carbon, and then the oxygen's already balanced, so we're just going to balance the charges. So to combine, I'm going to double up the manganese equation, and I'm going to combine and say 2Mn3 plus react with ethane dioate ions to make 2Mn2 plus and 2CO2. And this is what's happening in our next stage of our reaction. And again, two oppositely charged ions, they're going to attract one another. This stage is also going to be faster. So we can go back and we can look, we're now in this middle part where the rate is increasing. The Mn3 plus that we just formed is going to react with the ethane dioate ions to make 2Mn2 plus and 2 carbon dioxide. And we can see that the thing that we created in the middle, and then so an intermediate species, something we made but then used up in this reaction, was Mn3 plus. So that was our intermediate. So this is an example of where a catalyst is made in its own original reaction. We call this an autocatalyst. It's a subsection of homogeneous, so it's a type of homogeneous catalysis. And we can break down the steps and have a look, and we get this interesting shaped graph when we've got autocatalysis going on. So this is quite a common question on the exam for you. You do need to go over this a couple of times to get it into your head and make sure you understand what's going on.